automotive housing.
Hey everyone, I'm Dario, a software engineer in Adevita, in the Dutch team. Today I'm going to talk to you about how we optimized data transfer in Kafka and BigQuery use case a few months ago. Some spoiler, the open source had all the code. So if you have a similar use case, you may have a look to the Adevita Git. I will share also a QR code at the end of the talk. And let me know if you would like to use it and if it may be helpful to you. I will also like to share a couple of words regarding Adevita. Here there are all the marketplaces in Europe. Adevita is leads classified online, in all the nations which operates the marketplace owned by Adevita have top ranks in automotive, housing, furniture. Here in the Netherlands you have Marktplaats that most of you probably know. And it has a huge user base, monthly more than 120 million of active users. This gives us a lot of nice use cases that we solve, like the one that I'm going to present you shortly. The agenda is that I'm going to show you the problem and why we adopted a new solution. I will go through the design of the new application, Kafka to BigQuery, and then I will also describe briefly the CEO framework that we use to make the application scalable, and I will close up with what we obtained with the results. So, at the beginning, a few years ago, in my company, my team had to manage the migration from on-premise to Google Cloud, that at the time was the chosen cloud provider. And we had to set up a pipeline to move data that were available near real time on Kafka on a position in which the analyst could access data in a better way. And it has been chosen Dataflow for the task. That's because the cloud was Google. Dataflow makes this operation really easy. The nodes are completely managed by Google itself. No, we didn't need to worry about the scalability, and it was very easy to set this up. So it seemed a very nice solution. But what could go wrong with this? Well, after some time, the traffic of our pipeline started to grow a lot. And with that, also our awareness on the cost that this solution was giving to us. To give you an idea of the scale, our pipeline is processing roughly 2 billion of events per day, 20,000 per second. They are not big event, but neither small. Every event is more or less 5 kilobytes, coming from all the marketplaces of Adevita worldwide, of most of them. Some pain points that we had with this solution is that the cluster was composed by 200 topics, and this made the data flow really difficult to work with, because to every deployment, the training of the previous data flow jobs took a while as the startup of the new ones. And we tried different approaches with that, but to give you an idea, using one single data flow job was not starting up at all. And using a lot of data flow job was hard to maintain. And this was also, of course, giving us a lot of cost. So we decided it was time to redefine the architecture, this time going for open source technologies, and also instead of using nodes managed by Google, we used nodes managed directly by the common platform team in Adevita that made this operation very easy to us. They provided us some array nodes. We just had to write some configuration, and the nodes were readily available. This is the overview of the new solution that we rebranded Kafka BigQuery Express. You can find this in the Adevita Git with this name. It's composed by two applications. The first one, GCS Writer, that takes the data from Kafka and writes them in Google Cloud Storage, GCS, as a staging area. And the second application, BigQuery Writer, that takes the data from Google Cloud Storage and issue the jobs to BigQuery. let's have a look into these two applications more in detail. The first one, the GCS writer, has a Kafka consumer that's consuming all the topics and all the partitions. When these topics are in memory, it does some parsing and also some transformation, adding some fields. For example, we are adding the event date that will be used later as a partitioning key in BigQuery, so it was very useful to extract. Also, it does metadata management with the file names. This means that when we save the files in Google, in GCS, we also attach some information in the name of the file, like the topic from which it has been created, the destination table in which it will be loaded in BigQuery, the partition, and the offset. Every file has a suffix .avro and also a companion file .done. This is our way of managing offset. In this way, we know always from which offset to start, looking to the most recent and offset for every partition. Otherwise, we would have, after a file has been written, we could have some problem. A problem could arise in the committing of Kafka. In this way, we are safe. The second application is doing parallelly the consumption of the data from GCS and the construction of the loading jobs in BigQuery. These loading jobs are constructed every 15 minutes. This for two reasons. The first one is that the BigQuery has an upper limit of daily loading jobs that can be issued to it, and we would have exceeded that if we issued jobs every 5 minutes. The second is that we are giving some time so to the file to accumulate in Google Cloud Storage, such that we will construct the most efficient job as possible, one job for every table. And this loading operation is free of charge. It does not cost anything, just the networking. It also does the cleanup of this file, making sure there is at least one file with an offset for every Kafka partition. And we keep a state in GCS in case a job needs to restart, there is a restart or a crash. Some word regarding the schema. We use Avro everywhere in Kafka, in GCS, and also we load Avro file in BigQuery that automatically auto-detects the schema. What if a schema changes? This can be a problem, but if the changes are done in a back-compatible way, then BigQuery also doesn't care, and we change a lot our events, but always in a back-compatible way, so we are good in this case. I would like to now present Zio, that's the framework that we used heavily inside the application. It is an open source tool that allows to write a very scalable application with Scala. I will now list some points that maybe will convince you to use it. It's very easy to wrap any JVM technology with it. The overhead that it adds to the runtime is very minimal compared with other frameworks. It allows you to exploit the full power of the Scala compiler. The fibers that fiber for maybe you know green threads, that it's a different implementation of them in other programming language, allow for a very good concurrency model, and also gives you a nice tool to avoid leaking resources. This is how you can use Zio easily in your application. I highlighted immediately the type system that Zio uses in the return type of this function. It has 3 channels. The first is the environment, that is the requirements that functions need to execute. In the second channel, you have the error type, that can be nothing, a throwable or a custom error or exception. And in the third channel, you have the actual return type. You can use any service wrapped in a Zio. A nice way to do it is with a service pattern that's composed by 3 elements. This is the first, that's a trait, in which we declare the signature of our class. The second element of the service pattern is the actual implementation, here called matrix live. Live is just a suffix that's used as a convention in Zio. Then you have the dependency, In this case, the function does not have the dependency, but the class, the implementation has. And then in the implementation itself, all the logic is wrapped in @co.attemp. This will send all the logic to be executed over a fiber, and it will be scheduled underneath by CO in depending on the context of the other fiber in the application in the most efficient way. The third element of the service pattern is a companion object for the implementation. Here you declare a layer. That's how you wire your service in the main class. It acts as a builder pattern, so it declares how to construct the class. It can also declare how to close your class and remove it from memory. That can be very useful in some situations. Here you also see that we are calling the co.service method getting the dependency. We are not passing it, it will be injected automatically by CO, and you will do this in the main class. This is actually the real main of the open source application without any additional simplification. It's just declare the program and the logic that you want to execute. Here we are logging the configuration first, and then we start up concurrently the HTTP server, and also we declare the message processor and the .run method that will be the main logic of the application. It's not yet finished because we need to pass by the real implementations, and we do that like this. We provide them in this way. All the layers that we defined in our classes, in our services, will be passed by here, and CO will automatically resolve all the dependencies. Now I want to talk about the fibers. I talked before they are green-thread implementation. You can think about very fast and efficient Java threads. To give you an idea of the concurrency level, with few JVM threads you can execute tens of thousands of fiber concurrently. Also, they are very lightweight to create, and you can yield the execution of one fiber to the other really fast, without most of the overhead that you usually encounter with JVM threads and preemptive scheduling. Also, if Java threads are synchronous, fibers are executed in asynchronous ways. And also, comparing with Java threads again, in general, if you want to run a thread, you also can write a run method that returns void. This can be tricky to handle because you cannot act on the return type. Instead, in CO, everything is typed and composable. You can, as we saw before, have in CO as a return channel, and you can take that and act. But you don't usually do it because CO provides you a lot of nice utility if you want to do concurrency. For example, for each map over a collection, avoids you to fork fibers around. Okay, let's wrap this up. In the end, as I mentioned, we got a very nice cost reduction of roughly $40,000 per year. We went from a cluster managed by Google, composed by 13 nodes, each one of them with 2 CPUs and 16 GB of RAM, to 4 nodes, each one of them with 3 CPUs and 3 GB of RAM, managed by the common platform. Also, we gained a lot of control over the system. We switched from monitoring tools in Google to our own, and even it is a little advantage now. If the nodes are managed by us, if we want to SSH inside them, we can. But most importantly, we speeded up drastically the redeployment times, passing by hours to few minutes. The application worked quite well. We exploited the full power of Scala, and CO helped us to write it and make it scalable. It's working fine since almost 1 year, and we are very happy with that. Okay, so now we have some time for some questions. Thank you everyone for your attention. You can find my LinkedIn here, and also there is a QR code if you want to access the code of the Kafka Query Express.
does ZIO compare to something like CATS, or probably Scala Z has? Well, I haven't used Scala Z, but I know CATS has fibers and same like type modeling and all of that. So yeah, do you have any pros and cons of each?
Yeah, in general, also CATS is a very good library for this kind of use cases. We have it. We also have CATS in our code base, and also it sustains very high workloads. I would say it depends a lot by the tech stack that the team has and the knowledge within the team, which is. I don't remember to have seen a benchmark of these two technology recently. Yeah.
Yeah. Thanks.
Oh, I see a lot of.
In your initial solution, was there any application code written, or was it just structured on?
No, there was also some logic. All the enrichment that I showed in the GCS writer, and the fact that we parse the events, that we add some fields in the Avro events, where it was done also in Dataflow.
Yeah, and what was the tech stack there? Now the new solution is written in Scala with Zio, but what about the old one?
It was still the Scala. I think underneath there was Beam.
Okay, thank you.
For either of the steps for transferring the Kafka content, did you have to crack open the individual Avro events, or did you just rely on headers, or neither? Like did you need to deserialize the events from Kafka at any point in that?
Yeah, I think we are deserializing them, yes, because we are extracting the information regarding the date time from the event itself,
Right,
and then adding it on another specific field.
Gotcha, and that's what you were talking about with where the backwards compatibility for the Avro like schemas. Like you'd always have to have a backwards compatible set of events so that you didn't accidentally read an incompatible version when you send a new version. Is that?
I'm not understood.
Maybe, yeah. I think you answered my question, but thanks.
Okay.
You have mentioned this fiber, no? It's used for parallelization or for synchronization in your code, and then have you considered using also Java virtual threads? That is a new feature from Java 21.
Actually, I don't know much about Java virtual threads, but fibers are for concurrency, and if you want to synchronize some block, you need to make it synchronizable, or you need to make sure that's how the logic is atomic, for example. If you want something synchronized, you have some ways to do that in C, of course.
Thank you.
Thank you so much. First, regarding your presentation, I have a question on the initial solution. Did you consider using something like Flink or Spark for the transformation and ingestion part?
Yeah, we had this. I mentioned that we did this solution had actually some years made with Beam. So yeah, probably have some more modern now. Flink or Spark would have been the chosen technology for sure.
Thanks.
There's one more down.
Hello, thanks for your presentation. So, was the use of fibers was the crux of your cost reduction, or was there any other optimizations that you did overall?
Fibers helped us a lot to distribute as much as possible the load over the resources that we had available. So this is for sure the main way the application scaled that well. We also made some optimization here and there, of course, throughout the app. Yeah.
Thank you.
Hi, thank you for the presentation. I have a question regarding the scaling. Like, probably the load would be same all the time, right? So, how will you manage the infra in terms of the loads? For example, having more number of nodes to tackle the load, or sometimes
we go with a slight over-provisioning, so we don't have automatic auto-scaling. We over-provision it a little bit, and we are good. This is how we did. Before in Dataflow, it was managed by Google, the auto-scaling, but the nodes could only go up. So if the application scaled, then it couldn't scale back down.